So in today's video, we're going to go ahead and see how we can graphically correlate a function and its derivatives. And so over here, we have two functions. We have f of x and we have g of x on the right over here. What we're going to do for each of these functions is we're going to try to sketch their derivatives. So we're going to try to sketch f prime and then g prime. And we're going to see how we can kind of just use the graph of f to kind of get a sort of estimate or just a rough sketch of what the derivative may look like. And so let's go ahead and do that. And so using our knowledge of derivatives, we can immediately tell that whenever we have a stationary point, we're going to have a zero in our function, right? In our function's derivative, I should say. And so over here, it looks like we have a horizontal tangent line, and so the slope of the line will be equal to 0, and so we can mark that as kind of a 0 of f prime, right? Because we know that when the tangent line or the slope of the tangent line is equal to 0, then the derivative of our function is equal to 0. And we can do the same for this point right over here. We can mark this as one of the zeros in f prime, and same thing for this point right over here. And again, this is all just a rough estimate. This isn't going to be a very accurate sketch, but it's just going to give us a general sense of the shape of f prime of x. And so now we can go ahead and do is we can just look at the intervals over which f prime is going to be positive and f prime is going to be negative. And so, over here, when we're behind this point, when we're within this interval right over here, this region, then it looks as though f prime is going to be negative, right? Because we can tell just by looking at the graph of f that the function is going to be decreasing over this interval. And so let me erase this just to clean it up a little bit. So when the function is decreasing, we know that f prime is going to be negative. And so we know that throughout this entire interval, f prime is negative, and it seems to be decreasing at a very high rate. So it's going to be very negative over here, and then it's slowly going to start becoming less and less negative as we start entering sort of over here, approaching our stationary point down here. And so let's go ahead and see how that may look like graphically. So, we may be very, very negative down here, and then we're slowly becoming less and less negative until we reach our stationary point right over here. And so then we reach our stationary point, right? And at our stationary point, we're going to have a 0 in f prime of x. And then we start increasing, right? So f starts increasing, which means that f prime is going to be positive, and it starts to increase and increase more and more. And then eventually we can start seeing that it starts increasing less and less as we approach our next stationary point and switch concavity, right? And so what we can do is we can kind of mark that over here where we're very, very positive, and then we kind of start becoming less and less positive as we approach over here, and then eventually we hit our stationary point, right? And at our stationary point, that's going to be a 0 in the function. And one thing we can even think about is that f double prime right over here is going to be equal to 0 at our point of inflection. Like we can approximate this to be a point of inflection, and it looks like the slope of the tangent line to f prime at this point is going to be equal to 0. And so we can say that this may be a point of inflection, right? And let me actually just clean this curve up a little bit, make it a bit smoother. And so this is how our curve may look like as of right now. This is going to be f prime, right? And so we start to become negative again. We're decreasing at a very high rate right over here. So we become very negative, and then we let me actually fix that up. That looks a bit wrong. So we're very negative, right? And then we reach another point of inflection where we switch concavity and we become positive again. And then we just continue positive, increasing, right? Because we're decreasing after a stationary point. We reach a point of inflection around here, and then we reach our stationary point at which f prime is equal to 0, and then we start increasing again. And so we start increasing at a very high rate. And so that would be a good sketch of f prime. And using the sketch of f prime, we can sketch out f double prime. And, the higher order derivatives, of course, is going to become a little bit less accurate as we keep going onwards because we're just using our own approximations. But if we wanted to get a general sense of what f prime may look like, then this would be a good sort of rough sketch. And so let's go ahead and do that for this function g over here. And so it looks like for this interval, right, it seems as though we're increasing, but we're just increasing at a very, very slow rate, right? Because kind of over this interval, f prime is positive, right? But it's a very low positive number, right? The slope of our tangent line is positive, but it's a very small positive number. So it may, g prime may look something like this, right? But as we start approaching the origin, then our function starts to increase at a higher rate, at a greater rate. So the slope of our tangent line starts to increase, and so we can say that the derivative of our function starts to increase, and it becomes very, very high, significantly higher. And then eventually we'll reach the origin, right? And as we reach the origin, you could almost think of this as a sort of point of, not really a point of inflection, but yeah, I suppose you could, because over here, we almost have a, you can think of it, we almost have a, this at this point right over here, the slope of our tangent line as at a maximum, right? Because relative to every other point on this graph, it looks like we are increasing the most right at the origin. And so that can be kind of a maximum for f prime right over here. And so we could think of that as a point at which f double prime is equal to 0, right? And so we have our maximum, and then we start, we're still increasing, but we start increasing at a slower and slower rate, and kind of start kind of developing this asymptotic behavior. And so we can say that we start decreasing right over here and go back to 0. This almost looks like a normal distribution, but it really isn't, though. And so this would be a good rough sketch of what g prime may look like. And again, I encourage you to try different examples and to try sketching maybe the second derivative, the third derivative, to kind of get a general sense of how we can graphically connect a function and its derivatives. And so again, these aren't super accurate sketches, but they do help us kind of get a sense of how the function is behaving.